Welcome back to Mathematics 0110, the lesson on derivatives of exponential functions. What we've done so far is we've taken the derivative of e to the x and e to the x involved in product rules and e to the power of w, so e to the power of a function of x using a new type of chain rule. Well, it's not really new, it just looks new, but it's the same chain rule as before. Now we'll combine rules like product rule in this example and quotient rule in this example. We'll combine those with this new chain rule. So this function is, this f of x is two things multiplied together, an a and a b. The a is the x to the power of 3, the b is the e to the 7x. This means we need a product rule to take the derivative. So product rule will have a times b prime plus b times a prime. And I'll do those derivatives off to the side. A is x to the power of 3, so a prime is 3x squared using the power rule. B is e to the 7x. Here it's an e to the w type derivative. So b prime will be e to the w times w prime. So e to the 7x times 7, and I'll put that as 7e to the 7x. And we'll plug that into our product rule. So a is x to the 3, b prime, copying over from the right hand side, is 7e to the 7x, plus b, e to the 7x, times a prime 3x squared. Perfect answer. If the question says do not simplify, leave it alone. Leave it like this. And even in the long answer, or even the multiple choice, the answer may look like this too if this was a multiple choice question. Okay, next step. I'm going to common factor everything that possibly can be common factored. I can't common factor a constant out. One of the constants is 7, one of the constants is 3, but I can take an x squared out. They both have at least 2 powers of x. And they both have the e to the 7x, so I can take that out as well. The first part, I have my 7 and 1 power of x. My second part, all I have is a 3. So that is the simplest form. And I'm going to circle the one up above because I don't want you to think you have to simplify. And often, you'll be forced to not simplify. You'll be forced to leave it like this if it's a multiple choice problem. Okay, let's look at another one. Here we have a top function over bottom function. So to take this type of a derivative, we need a quotient rule. This is t over b. So my top function is e to the negative 2x. This is an e to the w type of a derivative, e to the w times w prime. So e to the negative 2x times negative 2. I'll write that in standard form, negative 2 e to negative 2x. Our bottom function is 1 plus 2x. That's a nice derivative. We just need the power rule. Derivative of 1 is 0. Derivative of 2x is 2. So we just get 2. And then we can plug that into our quotient rule. So h prime of x, according to the quotient rule, will be bt prime minus tb prime over b squared. So the bottom function is 1 plus 2x. T prime is e to the negative 2x. Oh, t prime is negative 2 times e to the negative 2x. And then I have minus tb prime minus e to the negative 2x times 2, all divided by the bottom squared, 1 plus 2x, all squared. And I'm going to circle that as a really good final answer, because that's how I'm going to want you to leave it. I don't want you to always simplify it. Leave it alone. But what if you did want to simplify it? Well, you'd have to common factor. And you might want to expand first, so I'll do that. Let's see, hold on a second. Okay, I'll expand first. So I have negative 2 e to the negative 2x, so the multiplication by 1, and then minus 4x e to the negative 2x, multiplication by 2x, and then minus 2 e to the negative 2x, all divided by 1 plus 2x all squared. And then we can collect like terms. We have the first term and the last term on top. They are the same type of quantity, negative 2 of something and another negative 2 of that thing. So we have negative 4 of those, negative 4 e to the negative 2x minus 4 e to the negative 2, or 4x e to the negative 2x, all over 1 plus 2x all squared. And then one more step, I'm going to common factor on top, that we can take a negative 4 and an e to the negative 2x out. So negative 4 e to the negative 2x, and we're left with 1 plus x. The negative has already been taken out. The 4 has already been taken out, and the exponential has already been taken out. All divided by 1 plus 2x all squared. And all that is generally not needed. That's the type of thing that a computer does when it solves a question. And you're not a computer. I use computers a lot. I do a lot of stuff with computation. I do my PhD in computational methods. So I know how to use them. I just think we rely too much on them. It robs us of an ability to do problem solving and to exercise our brains, to rely on a computer for everything. Okay, look at this horrifying thing. Compare this one to this one. They aren't structurally any different. We're going to have the same problem solving process. We identify that we need a quotient rule. We also can identify, based on this function, that we're going to have several places where the new exponential chain rule is going to be necessary. Attached to this one, I'm going to put an explicit instruction, because I don't think I'll have space to do it. Do not simplify. Let's go. Let's see what we have. So the structure is, this is a top function over a bottom function. So we'll need a quotient rule. Once we take the derivative, bt prime minus tb prime over b squared. Once we get all the pieces we need to plug into that formula, we're done. It says do not simplify. Don't look for anything else to do. So some of the pieces we have for free. The bottom function I'm going to plug in right away. E to the 3x plus x to the power 5. The t prime piece, I'm going to leave a big box for that. Minus the t piece, e to the 1 over x plus 5x. And then the b prime, I'll leave a box for that one. All divided by the bottom squared. E to the 3x plus x to the 5, all squared. So that's the structure of the problem that we're going to have. Now I just need to know what to plug into those two boxes. I'm just going to color code them, because why not? So the first one I'll make green, and then the second one I'll make blue. Okay, so the green one corresponds to t prime. T equals e to the 1 over x plus 5x. I'm going to rewrite that as as e to the x to the power of negative 1 plus 5x. Now I'm going to take the derivative. T prime is e to the w times w prime plus the derivative of 5x, which is 5. Now e to the w is just e to the power of x to the power of negative 1. W prime, the derivative of x to the power of negative 1. The negative 1 comes down, negative 1 times x to the power of negative 2. And I'm just going to plug that straight in the box. Actually, no, I lied. I'm going to do one more thing. I'm going to rewrite this as e to the 1 over x. And then I might as well do this too. Minus 1 over x squared, and then a plus 5. And I'll put round brackets around it so I don't get confused with the square brackets that are up above. Okay, so e to the 1 over x multiplied by minus 1 over x squared plus 5. That's the t prime. Now b the bottom function is e to the 3x plus x to the power 5. When we take the derivative, we're going to have an e to the w times w prime plus 5x to the power 4. So e to the w times w prime, we're going to have e to the 3x times 3 plus 5x to the power 4. And then I'll put that in traditional format, 3e to the 3x plus 5x to the power 4. And then I'll highlight our final answer in its full glory. Do not simplify. All right. So we've already seen the answer to this question at the beginning of the lesson on the first video on exponential functions. So I'll just say see slide, I think it was slide 3. I think it was the third slide. When we take the derivative, we'll get, when we take the derivative of b to the power of x, we'll get b to the power of x times the ln of the base, times the ln of b. I want to show you another way to do it. Yeah, you can go through the same limit process we just went through on limit as h approaches 0. Go through that again, leave it as a b instead of as a 2. At the end, you'll have the derivative of b to the x will be b to the x times the limit as h approaches 0 of b to the h minus 1 all over h. That's what you'll get. And that is the definition of ln b. But here's a second way to do it. And it's a neat trick. You're not responsible for knowing what I'm about to show you. This is not tested. What's inside the cloud? Inside this cloud, not tested. So y equals b to the x can be rewritten as e to the ln b all to the x. E to ln b, cancellation law. I can cancel them out and get b back. Now I'm going to use an exponent law. A power to a power results in the powers multiplying. So I have e to the x multiplied by the ln of the base. I'm putting the x in front so I don't get confused and accidentally throw the x into the log function. It's not inside the log function, it's multiplying the log function. So this is one of my defense mechanisms for not making mistakes when working with logs. Actually, the two defense mechanisms. One is to put brackets around what's being plugged into the log, and the other thing is don't put anything to the right of a log function, unless you absolutely have to, unless you have no choice. put other stuff to the left of the log function. And that makes it clear which things are being plugged in, which things are being multiplied. Anyway, now we're going to take the derivative. We're taking the derivative of e to the power of w, so e to the w, multiplied by w prime, where w is x multiplied by the ln of b. And remember, this is a constant. So when we take the derivative, dw by dx, or w prime, same thing, we're taking d by dx of x times the ln of b. And here's where I don't really have a choice. I'm going to common factor the constant out front of the derivative, so now stuff is going to be to the right of it. And I don't like that, but there's nothing else I can do. Times the derivative d by dx of x. And the derivative of x is 1, so I just get ln b. So my derivative of e to the w times w prime, I'm going to have e to the x ln b multiplied by ln b. And then recall that e to the x ln b, well, that came from just b to the x. That's how we rewrote it. So this is b to the x times the ln of b. So this is a second way to derive this formula, starting with the formula for the derivative of e to the x and the related formula for the derivative of e to the power of w. This is not a derivation, though. You couldn't use this as a proof because our derivative of e to the x and our related derivative of e to the w, that came from the method that we would also use to prove the derivative of b to the x. So anyway, just a neat thing that all these rules are consistent with each other. You can't break math as long as you follow all the rules. So in these two examples, we're going to deploy that formula with the chain rule. We're going to combine them. So the format of this one, this is e to the power of w. When we had e to the power of w, actually, do I have that here? I'll add it in here. And also, if f of x is b to the w, what is our derivative? F prime of x is going to be b to the w times the ln of b. That's the part that just came out of this. I'll do this, ln b times w prime. Oh, that's a bad multiply symbol. Okay, so b to w ln b, same as what's up above, the same structure, and we have to multiply it by w prime. Recall that the derivative of e to the w is e to the w times w prime. So here we just have an extra piece. We have a ln of the base. We don't have that piece when the base is e because the ln of e is 1, and we don't need to show a multiplication by 1. So in the next slide, I'm just going to highlight these two things. That's our takeaway from this slide, or the two things highlighted in orange, or a circle in orange, not the thing in red. The thing in red you could ignore for the rest of the course, probably beyond. We're going to take these takeaway messages and apply them here. So the first example, we have a function of the form b to the power of w, and we're asked to take the derivative. And I should have mentioned this right at the start. Pay close attention to the instructions. Sometimes you're asked to do something else to the function and not take a derivative. Like you have a function equals stuff, and the request is solve for x. Or the thing says simplify, and you don't take a derivative, you don't solve for x, you just rearrange it. So pay close attention. Don't take a derivative unless the question actually requires you to take a derivative. So sometimes it'll be explicit, it'll say find f prime, or find df by dx, or find the derivative. Sometimes it'll be less explicit, it'll be sneaky, The question might say, find the slope of the tangent line, or find the equation of the tangent line, which are also code phrases, as you know by now, for taking the derivative. So just be cautious. You have lots of things you can do to functions. Do the right thing. Do the thing that was asked, that is asked of you inside the question. Okay, so the derivative, according to the formula on the previous slide, of anything of the form b to the power of w will be b to the w times the ln of the base, so times the ln of b, times w prime. So w in this case is 9x minus 2x cubed. W prime is going to be 9 minus 6x squared. So let's plug everything in. 3 to the w, so 3 to the 9x minus 2x cubed, times the ln of 3, times 9 minus 6x to the power of 2. And that's a good way to leave the answer. It breaks some of the rules, so I'll write something else underneath it. We're supposed to put constants out front, so I'm going to put a ln 3 out front. And I'm going to write the polynomial piece, 9 minus 6x squared afterwards. And then I'm going to put the exponential, 3 to the 9x minus 2x cubed after that. And we could even go further. We can common factor a 3 from the stuff inside the brackets. So I'll put the 3 in front of the ln 3, 3 ln 3 times 3 minus 2x squared times 3 to the power of 9x minus 2x cubed. So that's like a back to the book thing. And actually, it's endless. You can simplify this until after the cows have come home, had more cows, and those cows have come home. So the answer that I want to see is the one that's in orange. Don't do weird stuff. Okay, next one. Use a different color for it. Well, maybe not the first part. First part is recognizing what type of function it is. This is b to the power of w. Different base b, different function w, but it has the same form. That means its derivative will come from the same formula. W in this case is square root of x, which we know is x to the power 1/2. When we take the derivative, which we're going to do because we're going to need it for the big formula, the 1/2 comes down, and we have x to 1 lower power, so negative 1/2. Okay, so, this is called h now. Might as well be consistent. Call it h prime is 7 to the w times the ln of 7 times w prime. Now we'll plug in the pieces. 7 to the square root of x times the ln of 7 times w prime. 1/2 x to the negative 1/2. And that is something to, again, don't fix it, don't change it, leave it alone. All types of wacky stuff can be done. Just because you can do it doesn't mean you should. Computers love wacky stuff. All right, next topic. Let's see what we got. Okay. Next topic is merging this topic, derivatives of exponential functions, with one of the other new topics that we just saw, which is the higher order derivatives, how to take second derivatives and third derivatives and so on. So here are two examples. We're asked to find the second derivative of this function x e to the power of 2x. To start off, we have to take the first derivative, and when we look at the function carefully, you should see a product rule. One part of the product, a, is just the x, and the second part, b, is the e to the 2x. So I'm going to label those x and e to the power of 2x. A prime, the derivative of 1 times x, is 1. B prime, we're going to have e to the w times w prime. So e to the 2x times 2, which I'll rewrite as 2e to the power of 2x. So we have ab prime plus ba prime. We'll have x times 2e to the 2x plus b e to the 2x times 1, which is 2x e to the 2x plus e to the 2x. I'm going to common factor for a good reason. E to the 2x can come out, and we have 2x plus 1. Now we need to take the second derivative. Make it autofocus. There we go. On the second derivative, I'm not going to use red to label the a and the b because I don't want to get confused. We need another product rule, but it's going to be a different a and b. Our a I'll call e to the 2x, and our b I'll call 2x plus 1. And if you reverse them, that's fine. It won't make any difference. So a is e to the 2x, b is 2x plus 1. So a prime, we have e to the w times w prime, so e to the 2x times 2, which is 2e to the 2x. B prime is 2 plus 0, which is just 2. So now taking the second derivative, oh, and I broke a rule. This is not equal, this is h prime equals. So this is the first derivative. Now I'm going to do the second derivative. So h double prime of x is going to be the blue ab prime plus ba prime. So a is e to the 2x, b prime is 2, plus b, which is 2x plus 1, and then the a prime is 2e to the 2x. And I'm going to write this in a more standard form. This is 2e to the 2x plus let's see, 4x e to the 2x plus 4 e to the 2x. And I should highlight the answer that's acceptable. So the answer that's acceptable is in orange right now. And then we can collect like terms. We have 2e to the 2x plus 4e to the 2x. That's 6 of those. And then do some common factoring. So 2e to the 2x. Oh, I'll just leave it. You know what? I didn't want to cause confusion. This is already confusing. Let's leave it alone. I will say that simplifies. I'll tell you what it simplifies to. So it'll simplify to the following. 2e to the 2x times, we'll have this one, hold on, so take that out, I get 1 plus 2x plus 1, so 4. I think it's this. No, it can't be. waste time doing it. I don't have really space to do it either. I'll leave it alone. You can do it if you want. But a common factor is into something nice. And then if you wanted to know the nth derivative, you wanted to know what does the 10th derivative look like, you can find the formula. So that's why I was kind of frittering away at that a little bit. For those of you who like that question and wanted to do another one, go ahead and try and maybe send me what the nth derivative is. Okay, next one, h double prime for a different function. In this one, we don't need a product rule. We have a constant times a function, which doesn't need a product rule, and another constant times a function, which doesn't need a product rule. The two function pieces are separated by a plus sign or a minus sign, so we don't need a product rule for that reason. These are just two separate derivatives. So this is a 2e to the w, and the one beside it is a 5e to the u. Just to use a different letter. You can use a blue W if you want, if you have different color pencil crayons, or markers, whatever you're using. If you want to use different colors, go ahead and use a red W and a blue W, but if you're using pencil or pen in your notes, choose different letters. So W and U would be good choices. When we take the first derivative, when we find h prime of x, we're going to have, and I'll color code these, 2e to the w times w prime plus 5e to the u times u prime. So let's plug that stuff in. 2e to the 3x times 3 plus 5e to the negative x times the derivative of negative x, which is negative 1. And then we can clean that up a little bit. I'll do that over here. We have 6e to the 3x minus 5e to the negative x. Okay, let's do it again. That's the first. Now we need the second. So h double prime of x will have 6e to the w times w prime minus 5e to the u times u prime. Now we'll plug in those pieces. 6e to the 3x times 3 minus 5e to the negative x times negative 1, which simplifies into 18e to the 3x plus 5e to the negative x. So that would be our good final answer. The nth derivative. What's going to happen? How would you write the nth derivative of this? Notice that each time you take a derivative, in the first term a 3 comes down. So you have 2 times 3 to how many powers of derivatives you have. So if you take 5 derivatives, you're going to have 2 multiplied by 3 to the power of 5. If it's n derivatives, it would be 2 multiplied by 3 to the power of n multiplied by e to the 3x. For the second piece, a negative 1 comes down. So you're going to have the 5 multiplied by negative 1 to the power of n times e to the negative x. That'll be the nth derivative. So sometimes that second piece will have a plus sign in front if n is an even number, and if n is an odd number, it will have a negative sign in front. So as a summary of the different derivative rules, we have a derivative rule for b to the power of x. Derivative of b to the x is b to the x multiplied by the ln of b. And here I have the formula with the ln b in front, and again, it doesn't matter. Order multiplication, it makes no difference where you put that. And there's an example on the right-hand side with a particular value of the base. What if it's e to the x? Special case of a base equals e. Well, the ln b part disappears. We get ln of e is 1, so we have e to the x times 1, which is just e to the x for the derivative. So on the right-hand side, there's no extra example I can give other than a product rule. What's the derivative of x to the 3 times e to the x? There it is, product rule answer. And then the other derivative formula, derivative of b to the power of w, where w is a function, that derivative is b to the w times the ln of b times w prime. And as long as you have all three pieces, it doesn't matter in what order you multiply them in, whatever order you're more comfortable with. I would warn you, however, if you're going to put the ln part first, like I have in the formula here, brackets to protect it from having b to w or w prime trying to sneak inside, because you can't sneak those things inside the log function. And two examples are shown on the right. One example has a base e, the other example has a base 7, and they both have the same format. We'll continue the next topic in the next video.